All right, thanks everybody. As Seth was saying, my name is Jacob Walker. I'm going to be talking to you today about implementing OOP, or object-oriented programming. In case you're wondering who the heck I am, I'm a full-stack developer. I do front-end code, back-end code. I really prefer the back-end stuff, though. I don't have an eye for anything visual, and I kind of just flounder when I work on the front end. So I like to think that I'm qualified to talk about stuff related to the back-end. I've got about 5 years professional experience. As you can see, I've been in front of computers for a long time. My career focus is on modern object-oriented PHP. This is like PHP right now is going through a renaissance. It's not the same as PHP from 4 or 5 years ago, 10 years ago. So if you haven't looked into modern PHP recently, you might give it a look. And if you want to stalk me, there's my website. Don't go to jacobwalker.com without the hyphen. That's not me. Or do, and then just you'll see what I mean. All right. So what is OOP? Well, object-oriented programming. All right. Thanks for coming out. If you have any questions, let me know. OOP. Object-oriented programming, this is one of 3 very popular programming paradigms. There's procedural code, which is what most programs and scripts start as, is you start at the top, you go to the bottom, maybe along the way you call out to other functions or something like that. Functional programming, which is not programming that uses functions, but it's a different style where like everything is anonymous functions and has to do with like global state. Like it's a whole different kind of style of programming, and it's really interesting as well. And then there's object-oriented programming. It's very well supported. According to Wikipedia, there's over 150 languages or known languages that have some degree of support of object-oriented features. And I mentioned degrees or implementations because while a lot of the concepts of OOP are the same across languages, not all languages support all the features, or they don't support them all the same, and they kind of take different. They all have different syntax and takes on them. So for this talk, we're going to focus on just PHP and Ruby. Why PHP and Ruby? PHP because that's what I'm good at, and Ruby because that's what I wanted to learn about. And I also know that we have a lot of people in this community that know Ruby or are learning Ruby. So this is all great, but why do you care? Object-oriented programming has several benefits, and this is not an exhaustive list. It can help to encourage structure both in your projects and in your code and in your styles of thinking, and it kind of, if you do it right, it forces you into smaller, more modular components. It can help your testability. Functional programming is also very testable. Procedural programming that relies a lot on global state is not very testable. And we won't really cover testing in this talk, but that might be another topic of someday. And if you are interested in test-driven development or talking about testing, like automated testing, I would love to talk about it later. One of the other benefits of OOP that people talk about a lot is how you can make it to where the code more closely resembles life and more closely resembles the domain that you're actually programming for, the problems you're trying to solve. And then just for organizational purposes, it keeps data and the methods that manipulate it together. So you'll see about that. All right, so most of this talk just covers the components of OOP, and my goal here is not really theoretical. I'm not here to talk about a lot of theory and why one thing's better than another or that kind of thing. The goal of this talk is that everyone here would be literate in OOP verbiage, be able to navigate an OOP code base when you're looking at something and you're like, what is an interface? Like, what does this mean, implement? I don't understand this. What's this keyword? This talk will expose you to all of the most common pieces of syntax of OOP so that hopefully you remember it, but even if you don't, you will be able to know, oh, okay, I know what I should go Google, and so I can go back and look at this. All right, so that was all introduction. Now we're going to dive in. Before we can talk about OOP or any of the other features, we have to define objects and classes. An class is the definition of a thing that you're talking about. It defines the information and behavior of a thing. And then an object would be a specific instance of a class. So, for example, if I have a class called developer, then Jacob and Seth would both be objects or instances of developer, of that class. Like developer is a type. Okay, so throughout the talk, when I do code samples, you'll notice here the language we're talking about is across the top in this little, I hope, legible block. To define a class in PHP or Ruby that doesn't do anything, it's really simple. You just, in both cases, you use the class keyword, then the name of the class, and PHP you use curly braces, Ruby you use end. On a quick side note, defining a class name, it's usually convention to have to use like Studley case or Pascal case, where you have the first letter of every word capitalized, and if it's multiple words, usually you would combine them together with no separators or anything. All right, so I have a class called developer, but that's just the concept. That's the idea of a developer. That's not any particular developer, right? So to get an instance or an object of that class, you use the new keyword. So in my examples, my PHP examples, we're going to use Jacob is a new developer, Seth is, and in Ruby you do developer.new. Not too much, not very different at this point. Well, before we move on, does anyone have any questions on this yet? That we have the class is the idea of the thing you're describing, and then an object or an instance is a specific instance. I'm using the word to describe itself, but I mean, I can't think of anything else. Okay. The next vocabulary word is methods. This is just what we call functions. In OOP, a method is a function on a class. Now, the purpose of class methods is that they provide access to the data that's on that class, or they perform some kind of action or behavior, or maybe both. So let's teach these developers how to code right now. They don't do anything yet. So we're going to add a method to my developer class. So I have a method called code. We're going to see in a little bit, we're going to expand on this syntax. This is technically acceptable, but I wouldn't copy and paste this into any program. So here, I have a class called developer, and developer has a method called code, and the contents, the body of this method is just I print LeetCoder. So if I get a new developer, we're going to call it Jacob. What you call it here doesn't matter. That's just the name of your variable. So this could be D, O, whatever, foo. So I have Jacob. Jacob's a developer, and I say Jacob code. And so then it prints LeetCoder. Let's see that in Ruby. I'm going to do this for all of the examples where it's applicable. I'm going to show how it works in PHP and then how it works in Ruby. So here, Ruby is a little different, but pretty much the same still. I don't say function code. It's def or define, definition. So I have a method called code. It prints LeetCoder, and so I say, okay, Seth is a new developer, Seth.code, and then it prints. So still, it's pretty basic stuff. We've got methods are functions on a class. Now, as just like a side note, if I went to this line right here after this, and I just typed code, I would get an error that says, well, code is not, it's not a method. I don't know what that is, because code is a method on this class. So so when I have an instance of that class, then I can call it. But this is defined within this scope. It's not defined in like the global scope or in the scope of another class like designer. Now, before we can talk about anything else, I wanted to go ahead and cover constructors or initializers. Usually these are just called constructors. This is a special method. in a lot of different implementations of OP, there's magic methods that are called at certain times without you actually intending them to, or explicitly asking them to necessarily. A constructor is a special method on a class that is automatically called whenever you make a new instance. So to show that, the way this works in PHP is if you have a function, if you have a method on your class called __ construct, and PHP knows that this is your constructor. This is as soon as I make a new developer, so I say new developer, as soon as I do that, it calls my constructor method. In this case, I'm printing stuff like you would never print stuff in the constructor. But I mean, so here I'm printing hello world. There it is. Hello world. In Ruby, constructors, they use the word initialize. So you might maybe call it initializer. I don't know if that's a concept. If Rubyists do that or not. Over here, it's the same thing. As soon as I say developer.new, not only do I get an instance of developer, which I'm calling Seth, but just calling developer.new outputs hello world. So to recap, constructor is just a method that gets called as soon as you instantiate an object. In PHP, we call it __ construct, and in Ruby, it's called initialize. So we have classes, they have methods, they can do things, but we need to add data, because what's a developer with no data on it? Like, it's just kind of, it's still too abstract. It doesn't really resemble what I'm talking about. So typically, classically, we would refer to the data of the object as properties. So a property is just some piece of data that's attached to that class. So we're going to give our developers names. They didn't have them before. This is one way to do it. Like I mentioned before, later you'll see why this is a slightly bad practice, how I'm coding this. But here I've got this method, this class developer. It's got the constructor. This is the thing that gets called as soon as I instantiate it. And now, instead of just having two parentheses to just, now I'm starting to accept arguments. So just like a function not on a class, I can accept arguments. So I'm accepting something that I'm going to call name. And then I'm going to add it to my instance. I'm going to add it to the object that I have. In PHP, let's look at the syntax here. This is just $name. If you've ever used PHP, then you're familiar with this syntax, that this is just how you have a variable. This is like a local variable. As soon as your program leaves this method, that variable doesn't exist anymore. It's just local for that scope. But with this syntax, you have the word this, and then this arrow. So from here to here, this is all the part that gets built up before the word name. So developer is a class that has property name. And the word this also suggests to you that it's referring to a particular instance. It's a developer. So if I had more than one developer, it'd be like, well, this developer's name is Jacob. This developer's name is Matthew. This developer's name is Brian. This developer's name is Jim. So when we're going to jump down here. When I come to this line and I say, all right, Jacob's a new developer, and now I can pass arguments in. And this is kind of a special thing about constructors, that when you're making a new instance, if you pass in arguments, that's what gets passed to your constructor. So I have a new developer, and I pass in Jacob as this first argument. I added another method, just for examples. Developers know how to greet people. When you walked in the door, I tried to greet you. And in this case, I print, hi, I'm, and then it prints the name, right? So when I say Jacob greet, it says, hi, I'm Jacob. Let's look at that in Ruby. Really similar. Ruby syntax, if you're not familiar with it, doesn't typically require parentheses, like in a lot of classical programs, that like we'll see style programs. So when I define my initializer method, my constructor, I'm going to tell it that I'm going to accept one argument called name. When that argument comes in, now looking at this syntax, This is a local variable, so this is just this variable only exists for the life of this method. This with the @ sign in front of it means it's an instance variable. It's a property on that class that class is going to carry around. So like in PHP, we said this name, and in Ruby it's @name, and that just means it's a class property. So here when I say developer.new Seth, Seth, the string, gets passed in as the first argument to my initializer, which gets assigned to this property name. And then when I set a Seth.greet, it calls this method greet. In Ruby, if you're not familiar, this is how you can do string interpolation, where you can just embed variables straight within strings. So when I say Seth.greet, it says, "Hi, I'm Seth." And next, something else. So, all right, before we move on, this is, if this was like truly just a 101 class, we could stop right here and just say here's classes. They have properties, they have methods, you can add data, you can make it do stuff. But the objects of the classes that you write probably wouldn't be very good until you learn the rest of this. But before we move on, does anybody have any questions? And at any point, if anybody does have questions, please interrupt me and feel free to ask. Okay, so now let's talk about inheritance. Inheritance is another. This is another feature of OOP that is pretty classic. Some languages don't implement this. Most of them do. So when I have keywords here, it's not very bold. I don't know if you can tell, but the words that I've bolded are like OOP words. So the idea of inheritance is that one class can extend another class. I can take something generic and make it more specific. So the child class inherits properties and methods of the parent class. So the keywords here are extends and inherits. Let me show you what I'm talking about. So I might have a class coder. Well, really, I probably wouldn't start with this generic class. Usually, like a problem comes in, and I just start with the thing that I think makes the most sense. In this case, I needed to have a class called developer. But then I'm going to find that I need something else. I need a more generic version of that. Developer's too specific. So, I mean, I'd say a developer is a coder. So, like, sometimes you might replace this word extends. This is a keyword in PHP. You might replace the word extends with, like, is a, like the two words. So you could say developer is a coder. So, for example, like a square is a rectangle. Rectangles are not necessarily squares, but a square is a rectangle, right? So I have this class coder, and look, encoders code. So in this case, when you code, it prints the word code. And developers, which is a subclass or a child class of coder, developers develop. So developers print develop. But developers can also code, right? So I have Jacob as this developer. Oh, this is, I've printed too many times. So if you ignore this, let me see if I can do this. When I say Jacob code, it outputs code. Because Jacob is a coder. I said Jacob new developer, but because developers are coders, when I say Jacob code, it's like, well, I know I have that method. I inherited that method from my parent class, so I know how to do that. If I say Jacob develop, then that works too. If I went the other direction, say I took, like, my son Carter, he's 2.5, so maybe if he is a coder but not a developer, if I say Carter equals new coder, and I say Carter code, then okay, it would code, and I say Carter develop, and it would be like, I don't know what you're talking about. That's not a method that I have. I don't know anything about that. Let's go over that again in Ruby. So here I have a class called coder. It has the method code, and when I call code, it's going to print code, or put the string, put string. In Ruby, when you extend classes, you don't use the keyword extends. Ruby is all about, not all about, but one of the key features of Ruby is short syntax and things are concise. So they use the like a less than sign. So it's like a left arrow. It's saying that like developer, like all the properties and methods of coder are put onto developer. So developer extends coder. And here's the exact same thing. When I say Seth is developer.new, Seth code, Seth develop. So that's just basic inheritance. It gets more complicated. Another thing to think about is that you can also inherit types. So programming, we have types. We have like a number might be of the type integer or float or double, or I might have the type Boolean, true or false, or maybe the type null or the type string, or in a stronger type language I might have all sorts of types. Well, objects have types too, and that they are of the type whatever their class is. Child class inherits the type of all parent classes, and that's important. It's all parent classes. So here's an example. I've removed the methods because they don't serve this example at all, but I still have developer, which extends coder, and then I have coder, which is the base class. So I have dev and coder. Dev is a developer, coder is just a coder. So in PHP, there's a keyword instance of, which you have like a variable on the left, and then a class name on the right, and so it says dev instance of coder, and that's going to return true or false. So in this case, is dev instance of coder? Well, yes, because as we said before, extends, you could think of that as is a. So is a dev a coder? Well, yes, dev is a coder. Is dev a developer? Well, yeah, that one's pretty obvious. But then here my coder class, coder is an instance of coder? Yeah. Coder is an instance of developer? Well, no, it's not. So what's special to note about this is that this property, this object right here, it satisfies both of these types. So you could use this like instance of to say when I get an object in this function that I'm writing, if that object is an instance of coder, then I'm going to take some particular action on it. Or you could define a function that says a function that only accepts coders. Like if you give me anything that's not a coder, I'm going to complain. So like if you give me like a monkey wrench, a banana, I don't know what that is. Coders, I know what coders are, so I can work with that. I don't repeat that example in Ruby. I don't think it would serve much. But Ruby does have an equivalent for instance of. In OOP, sometimes you'll have object explosion, and that's not a keyword. That's just something that kind of happens where you end up with just all these different objects, and sometimes it's good, sometimes it's bad. It just depends on how well architected it is. But you can get into these class hierarchies. There's no limit on the number of superclasses that can be upstream from any given class that I'm aware of. I didn't do a lot of research, but maybe some language has a limit. Now, and another thing is that multiple classes can extend from the same base class. So I mentioned my son Carter, right? I have another son, Kel. Like Kel and Carter extend from me, like they inherit my properties and types. PHP, Ruby, and a lot of other languages will only allow a single parent per class. This is referred to as single inheritance. Some languages actually allow you to extend from multiple classes, multiple inheritance, which can get into some tricky kind of situations. Here's an example. I've removed all the properties and method, and I've pulled the curly braces up onto the same line just to save space. So we had coder, right? Developer was a coder. Let's get more generic. Let's have human. So I have a class called human. I mean, I assume that all of your coders are human. So I have this human class. A coder is a more specific version of human, right? Over here, my beautiful graph. And a developer is a more specific version of coder. designer is not necessarily a more specific version of developer. Like, I don't have to just keep going one in a line after the other. Designer also extends coder. So I have two classes that are extending from this class. So developer and designer both extend from coder. So if we were going to do the tests that we did before with instance of developer is a human, well, I like to think so. Designer is a human? Yes. I mean, this is not class human, and I don't extend from class human, but I extend from something which extends from something which extends from something which extends from human. So yes, I meet the basic criteria of humanity. Now you might be saying, well, some people are developers and designers. Okay, well then you would have like a more specific thing here that says class multi-purpose that would extend from both, and you would be at that point in a multi-inheritance language, which is not what we're talking about here. All right, moving on from inheritance, we're on to the next thing now. But inheritance is kind of a big concept. So I'm going to stop. Does anyone have any questions or want to call me out on anything I misspoke or anything? Okay. Yes. Just go ahead and just after like every slide, be like, any questions? Any questions? Okay. So I'm a developer, and I have properties. There's data. There's things about me. But I don't want everyone to know everything about me, right? So there's access modifiers or visibility controls. These are keywords or language constructs that you can use to control who has access to the different properties and methods of a class, the data and the behavior. So this is where our talk is going to diverge between covering PHP and Ruby. In general, both languages fit this description. Something that is public, that's available for anybody. Anyone can know that, and I consider this public knowledge. It also means that I consider it to be part of my interface, part of like a class's API. Now, not talking about like a REST API, but talking about this is the stuff that I publish and make available. So if I change one of these things, I have to be careful because other things might be relying on it that I'm not aware of. Things that are private typically are not available for public consumption. And things that are protected, this is like private, but it has exceptions, and we'll learn about those. So like I said, we're gonna different languages will give different meanings to these keywords. So first we're gonna cover PHP and then Ruby. All right, taking back to those three words again. In PHP, again, this controls properties and methods and who can see them and who can access them. Public, this is almost everyone pretty much, all languages use this the same as public. Anybody can do it. In PHP, a private property or method is only available to that class, but it's not available to child classes. So if there was, in our previous example, we had coder and developer. Coder has a private method. Developer can't access that. It doesn't extend down, and like it doesn't trickle down the hierarchy. In PHP, protected methods are not available for public use, but they are available for child classes. They do go all the way down the hierarchy. Public things always go all the way down the hierarchy. So not talking about, let's just talk about public versus private. So I have my class developer, which we're going to use for almost this entire presentation. And right now, we had a property called name, and we added a new property called secret. So this is private. No one can know my secret. In a previous example, I'm going to just do this for a second. Nope. This one. So previously, right in the constructor, I just set this property name, but I didn't declare it anywhere. This is a bad practice. Properties should always be declared and given a explicit access modifier. Because PHP is a loosely typed language, this is okay. You can do this. Like it's okay, as in the compiler won't throw a fit about it. But this would be much better if, like, somewhere up here, like typically these come at the top, there was a line that said public name, that I have a property called name and it's public. We might come back to that slide. Okay, so I have this property name and I have this property secret and it's private. So I make a new developer. We're going to call it Jacob. I'm going to go ahead and just set Jacob's name. So I'm setting the value of this property from, at this point, I'm in like global scope. I'm not within the scope of this class. I'm just in some scope. I'm using this class, and I'm reaching in and just making this a fact. I am changing its state. And I can pull it back out. When I say print Jacob name, it prints out Jacob, because that's what I just set it to. Now, in this case, secret is a private property. So when I say Jacob secret equals bar, PHP is going to throw a runtime exception and say, no, this is a fatal error, that you cannot access private property secret. Similarly, if I were to try to pull that information out, to print it, or to put it in a report, or to send it in an SMS to all of Jacob's high school class, then it would say, no, this is a private property and you can't do that. So what if I have a private property, but I do want to grant some public access to it? Sometimes private properties are just used for internal purposes only. Maybe it's a counter, or maybe it's some kind of resource, some kind of handler, something that I'm going to use within my class. Or what if it is a property that I want to make available, but I want to have strict control over how it's accessed. And this is actually typically considered a best practice to keep properties private and then expose them with functions. And the convention is to use getters and setters. Typically, they follow this kind of pattern, where if my property is called name, my function is I'm going to have a function called getName and a function called setName. SetName accepts a variable and sets it on this thing, and my getter just returns the thing. So now when I say Jacob's new developer, if I try to just say Jacob name equals Seth, it would say, no, that's private, you can't do that. But if I say Jacob set name to Seth, okay, that's fine. If I want to print Jacob get name, that works fine. Does this kind of seem like overkill? I mean, like, I'm effectively doing the same thing down here that I was doing before. Like on the previous slide with name, I would say Jacob name equals Jacob. Print Jacob name. This only takes 2 lines. The other slide takes like 12 lines. Sometimes it can be overkill, but it's still worth it, because what if I want to add some validation that says when you try to set name, if that is more than 128 characters, well, that's ridiculous. Like, I can't accept that in my domain, so no, we're not going to take that. Like, maybe I'll throw an exception. Maybe I'll return some error code. Maybe I will just truncate it to 128 characters and just ignore anything else. Same with getName. There's a concept of lazy loading. So if instead of querying things from the database directly, if maybe I use like an ORM like Doctrine or Eloquent, what if I have some class that represents something that is in my database, and initially when you fetch it out of the database, it just has like an ID on it. I don't fill it out with everything. But as soon as you call something like getName, I'm going to say, hold on. Let me go get the rest of that information from the database real quick. Okay, I have it. Okay, yeah, print returns. Oh, Jacob. My name is Jacob. If name was a public property and I decided I wanted to start doing that, I would have potentially a very hard task ahead of me of going through my entire code base and finding every place where something might be accessing public properties. But if they're private from the beginning, and I know everyone is only going through these getters and setters, then I have a single point of control, like a single point in which I can add some validation, I can add some lazy loading, or I can add anything like that. So getters and setters are good. Your question? Too close? Oh, I bet it is. Anybody got a razor? I'll just go ahead and shave real quick. Thanks, man. Ask him if this is any better. We talked about public. We've talked about private. The third access modifier that we'll cover is protected. Remember I said protected is like private, but with some exceptions. So I'm not going to do the full example here, but here I have a class called coder, and I have a class called developer. Developer extends coder. Name is protected, and then this variable code style is private, and like maybe there could be something else on here that's public. This property code style is private, and in PHP that means that it's not available to the public and it's not available to child classes. So within this scope, so if I had a method on here that was going to try to do something, it would not have access to code style because that's private, and I don't inherit that when I extend this. But name is protected, so it's the entire way down the hierarchy it's available. So I can access name, but not code style from within that scope. So we just talked about properties, and remember classes have properties and methods. So in PHP, public, private, protected, those keywords mean the exact same things when they're applied to methods. So as a developer, I have this function greet. I'd say hello there. I have another private function, reveal secret. No one gets to know this. That is not available outside of this scope. You ask me, you tell me to greet? Okay, I'll say hello there. You tell me to reveal my secret? We're going to fatal layer. This is not appropriate. I am not okay with that. I couldn't think of funny examples for this one. So here I have a class coder again, and then developer, which is a coder. I have a private method, a private function called secret. This is really secret. Only the coder class can execute this. And I have a protected function, kind of secret. So it's not available if you're not in the club, but developers can call kind of secret. Now I should point out that here within this scope, I'm in the global scope, and I can't call either method because they're not available for the public.
But if it was a public function, you could call it code.
Yes.
But if it's protected,
Yes. Yeah, if it's protected, means it's only available within the hierarchy, within my inheritance chain. That is visibility and access modifiers in PHP, and it's also pretty close to access modifiers in Java, C++. Those languages will add some other access modifiers, sometimes treat them a little differently, but that's like classic access modifiers. Now we're going to change directions. We're going to talk about visibility in Ruby. This is actually, like, this section of the presentation is where I spent the majority of my time researching and putting things together, because the classic PHP style, C++ style, is ingrained in my head. It took me a long time to get my head rewired to understand Ruby access modifiers. Hopefully I can relay it all to you in a short amount of time. So in Ruby, this controls who can call methods. Previously I said that it controls properties and methods, but here it just has to do with methods, so you'll see why in a minute. Again, it's the same three words, public, private, and protected, but they have different meanings. Like I said, everyone agrees on public. Public just means public. It's available to everybody. Private means it's only available within my class, like coder. It's also available in child classes, like developer. Like, private just means not public, really. But only this particular instance. Protected is like private, but it's available to other instances. So, like, Seth's a developer, I'm a developer, I have a protected method. We can exchange that information because we're all developers, but the public cannot. So let me show you what I'm talking about. Well, first I promised I would explain why I didn't mention properties before. And that's because in Ruby, properties are effectively always private. And this is something I like about Ruby, that you don't have the option of making public properties. So in this case, here in my initializer, as soon as I initialize this thing, I have a property called secret, which is private by default. If I want to make it, let's pretend like that says name. Just go ahead and change that in your heads. No, wait, what am I talking about? It's fine, how it is. Secret, yeah, this is secret. But I also add these properties on my class. I have one called name, and then this is, in Ruby, this is how you make like set name. So this would be get name, and this is set name. Notice the equal sign right there. So I make a new developer, and I'm going to set the name to Seth. And then I'm going to pull it out, and it's going to print Seth, and that's great. So I was able to use this function or method to set the name, and I use this method to get it out. Now, name is still a private property, but I've exposed it with this. Now, it just looks like you're accessing a property here. That's just how Ruby works. You're not actually accessing the property. There is no property access outside of a class. There's just a method called name, and so you're calling it. Now, if I try to call secret, what I get is a no method error. Now, in PHP, remember, this would be fatal error. You're trying to access a private property. In this case, it's just saying, I don't have a method secret. I don't know what you're talking about. So that secret foo is not available. Now, like I said before, Ruby really likes short syntax, and has a lot of like syntax sugar and convenience. So where previously we would write like a get name and a set name kind of function, this keyword here, attribute accessor, like this actually is I think it's a function really, not a keyword. Like when I call this function and I tell it name, it's going to go ahead and just define a get name and a set name function, a getter and a setter on my class. So all I would have to have is just like attribute accessor, and then you can give it like a comma separated list of the properties that you want to make available with getters and setters. And if you want to override it and make your own, you can later. So it's really convenient. You typically wouldn't have all three of these in a row like this. If you don't want to make a getter and a setter, you just want to maybe make a getter, you can say, well, give me an attribute reader for name. Like people can ask me for the name, but no one can change it. Or maybe you would do attribute writer, where it's like, well, you can give me something, you can give me a name, but you can't get it back. I won't tell you what it is. And again, secret is still secret. We never did anything to make that available. Okay, private methods. When I was learning Ruby, this was one of the first things I learned that really struck me as different from other languages. In PHP, if I had a function and I wanted to make that function private, then as part of the function signature, like when I'm actually writing it, I would say the word function private in here somewhere. That's not how it works in Ruby. I have some functions, and like as I'm making functions, they are public, and then I call private. This is not a keyword. This is a function. This is the function itself. And when I call it, it's being invoked, and it tells Ruby that from here on, everything else I tell you is private. Don't even like these should all be private from this point on. So I could have 100 methods under this keyword private, and they would all be private methods. So here in the global scope, when I say Seth developer new, Seth greet, hello there. When I ask Seth to reveal his dirty secret, it's no, that's private method. Well, the development community. Ruby likes to give you options and alternative ways to do things, and you could do it the way I did before, where you just call the word private, and it says from here down everything's private. Or if you call the word private and you pass it properties, identifiers that match function names, then it says like, hey, that function I told you about a little bit ago, reveal secret, that was private. So don't tell anybody about that.
In the current version of Ruby, you can now put private in front of the
Oh, you can put it like right here. Is that Ruby like 2.0.0 or I don't know. Okay. I would assume they did that to make it more comfortable for people coming from classical kind of backgrounds. He did. This is good. Chime in. So private methods, unlike PHP and C++, and unless this has changed in newer versions, which I doubt, private methods are available to children. They are available to classes that extend it. We're going to have to scroll this down a little bit. So I got a class called Coder. I tell Ruby, please give me a getter and setter for password, right? But make it private. That should be a private thing that only Coder and any classes that extend Coder can call. Now, I made the getter and the setter private, so how am I going to get a password to begin with? Well, in this implementation, I accepted my constructor, right, and initialize. So I have developer, which is a coder, and in this case, I don't have a method called password. I have a method called reveal password, and it returns password. So I'm actually a child class is taking something that was private and making it public, effectively. So here I have developer.new, and the password is banana, the capital B. Got to have a different case. So because developers are kind of dirty sometimes and break convention and reveal secrets and things they're not supposed to, I can say, Seth, reveal password, and he tells me banana. It's banana. This method is still private, though, because I didn't do anything to change that. I'm sure you could, and you can change everything on the fly. But I didn't. So password, that method, that's still private, and I can't call it from outside of the chain, the club. Now this one gets a little weird. I'll try not to spend too much time on it. So Ruby private is like PHP protected, and they agree on public. So then what's Ruby protected? Well, in Ruby, protected means that it's only available within the hierarchy, but it is available to other instances of the same class. You could actually do that in PHP as well, that are available to other instances. But let me just give you an example. You can see what I'm talking about. I have this class developer, and I want getters and setters from, I have two properties. Hacks, this is the number of hacks that this developer has written in their lifetime. And power, this is like their power level. Now, power is a protected method, which means it's not available to the public. It is available within our hierarchy, and it's available to other developers. Hacks, that's a secret. That is private only, not only my hierarchy, and only for this instance of developer will I let you know that. So let's scroll down a little bit. Oh, a little bit more. So now in this implementation, I'm just accepting this data through my initializer. So my initializer accepts two arguments, hacks and power, and we're just going to go ahead and set these on my properties. And then I define two methods. Is stronger than, and in Ruby convention, methods that end with a question mark will return like a Boolean, true or false. So is stronger than, and it accepts another dev, another instance of developer. And is hackier than, it accepts another developer. And in both cases, I might have pointed this out before. If you're not familiar with Ruby syntax, it doesn't require you to use the word return in a method. It's just the last expression evaluated in a method is the return value. So if I just had a method and I just wrote the number 1, the return value is 1. It's just like saying return 1. You can say return 1 if that makes you more comfortable, but it's not the convention and it's not required. So in this case, I have this expression that does this test. I say, well, I want to compare my power to other dev.power to see who's stronger. And then I have this test. It's hackier than. I want to compare my number of hacks to the other dev's number of hacks. We'll see. So let's scroll down a little bit more. Okay, so I've got Seth is a developer, a new developer that has written 83 hacks in their lifetime and has a power level of 9,001. So over 9,000. Right? That's pretty much why I went this direction. Jacob is a developer that has written 174 hacks, but only has a power level of 8,999. So if I take this object Seth and I say Seth is stronger than Jacob, yes, because Seth's power level is 9,001, Jacob's is 8,999, And on this instance, when I say is stronger than, now at this point we're talking from the point of view of Seth. So Jacob is the other dev. So Seth, so this is like basically saying like Seth's power, Seth.power. So Seth's power greater than other dev's power? Well, yes, it is. So that's going to return true. And then here we get that return value. Seth is hackier than Jacob? Well, no, he's not. Jacob's written a lot more hacks. But that's private. So when Seth tries to say other dev.hacks, he's going to get this no method error thrown in his face to say, you know, that's a private method. You can't call that. So it's a little different. But we're done talking about public, protected, private. So does anyone have any questions on access modifiers, what they're for, why you use them, how they're different between PHP, C++ styles, and Ruby?
So you mentioned previously that PHP uses Ruby. How is that?
It actually just works that way by default. So the question for anyone listening was in PHP how you can make it to where private and protected things are available to other instances, and they just are automatically. You don't have to actually do any special syntax, and you would do it for the same purpose of if you have something that's private or protected and you want to implement some kind of function to compare two objects, because you want to know which one's greater than. Like that's a really common use case. Is you want to say like I have these two things and I want to know like I just want to be able to use like the greater than or less than operator and know which one's greater. And the idea is that when you're within this scope, you're within the scope of that class. So hopefully you know how that class works because it's your class. That's what you're doing. But other classes don't know how this works. So like in my project, if I use Composer and I pull in some third-party library, I only know the public methods of those classes. I don't know or need to know anything about their internals because that's beyond that's beyond what I could know and what I should reasonably be expected to know. But if it's a class you're writing, the idea is that you would know. Uh-huh. Does someone have a question? Okay. All right, moving on. The next thing we're going to talk about is method overriding. When you Google for this, maybe I shouldn't even say this, it might introduce confusion. But if you Google for this, there's a concept of method overloading and method overriding. We're not going to be talking about method overloading. That's for strongly typed languages. Method overriding, this is where a child class can override, in bold keyword, can override or redefine a method that was defined in one of their parent classes. Okay, so I have the class coder. Coder has a public function type. What do you call types? Well, I type like this, right? Developer extends coder, and I'm going to override the function type. So when a developer codes, it's like, JK, I type like this. So this is, my wife thinks this is what I do at work all day, literally, with my hands. So when I have an instance of developer and I say Jacob type, it's going to output JK, I type like this. Because I've overridden that parent method and changed its behavior. There's a lot of reasons you might want to do this. If you have something that's more specific than the parent version and needs to be different, or if you just want to add to it, like add a little bit of information. Oh, I do have a functional example for this one. So I mentioned testing before. If you're not familiar in PHP, one of the kind of the de facto standard of PHP testing is PHP unit. And PHP unit gives us this class, PHP unit framework test case. It's not one of my classes. I don't know anything about its private and protected things. It's just something I've included as a third-party thing. But I'm going to make my class called testing base, which extends PHP unit framework test case. And with this class, I want to, this is going to be the class that instead of, when I actually write my test, instead of extending PHP unit framework test case, we're going to extend my base class because it adds some additional functionality. In this case, it adds a logger. So I have a property, a protected property called logger, and here in this function setup, we're going to instantiate a new logger, and we'll just pretend this is a class I defined in my project somewhere, or maybe I pulled this in from yet another third-party kind of thing, like monologue. So setup is a function or a method that gets called at the beginning of a test. So if you extend my testing base, the first thing that's going to happen is we're going to go ahead and instantiate this logger so that I can make it available during my test run, during my operation. And for most of my tests for my application, I use this testing base, and everything's great. But then I find out that I need a lot of tests that have to do specifically with payroll, because I'm writing some kind of payroll system, or some system that interfaces with payroll. And I found that I was doing this line right here and this line right here. I was duplicating that in all of my payroll tests. I'm doing that all the time. So I would make a new test called payroll test, or I mean, I guess even if I don't have other ones that are going to extend from this, this could be the end of the chain. But so I have this test payroll test, which is going to extend my testing base. And now I'm going to override the function setup. So when I have a payroll test and Phpunit starts running it and is going to start executing my test, it's going to call setup. Well, I still want the logger. I still need that. Like, I don't want to get rid of that. I just want to like kind of extend this function and make it do more stuff. So in OP, there's usually some way for you to call methods on a parent class. And in this case, in PHP, it's use the keyword parent followed by the double colons. So you say parent : setup. So we start here, we get here, we go here, we do this, we come back here, and then we move on with the rest of our setup function. In this case, I'm defining the payroll engine that I'm going to use as part of these tests. So this is method overriding, and if you want, you can, and if it's appropriate, you can also call the parent class. Now, like I said, remember, the hierarchy can be as tall, as long as you want. If it's really long, that might be a sign that you're doing something wrong. But if I had like 20 classes in a row that extended each other in like this tall line, and each one of them defined a method called setup, and each one of them called parent setup, like if you instantiated the one at the very bottom of the chain and you called parent setup, it would go all the way up, as far up as you go. Like, and this would just go like one level up to my parent. From this scope, I don't know, like it wouldn't call like PHP frameworks setup, it would just call the parent setup. You can do this in Ruby as well. So it's the same idea. I'm not going to use two examples. We're just going to do one example to cover both points, like how you do it and how you call parent methods. So I have a class now called Dancer. We're going to liven things up a little bit, get away from our coder and developer example. So I have a dancer, and when you ask that dancer to dance, they boogie. Then I have disco dancer. A disco dancer is a dancer, and they extend dancer. And I'm going to change the meaning of dance, but I'm still going to call my parent method with, in this case, you use the keyword super, so it's like the super class, the one above. I'm going to print boogie woogie. So Seth is a disco dancer, and when I say Seth dance, you get boogie woogie, because in this case I called super, so I called this one, and then I called this one, and so then you get it all out. There is kind of a side note here, and this is a really convenient feature of Ruby. Let's say dance accepted arguments like duration or direction or motivation, maybe. If I had these arguments here on dance and up here on this dance, when I call super, it's like, okay, I got this. I'm just going to take all of those arguments and I'm going to pass them on to the parent method as well, because I'm going to assume that's what you want to do. If that's not what you wanted to do, you can explicitly, like, use parentheses or don't, explicitly pass arguments to super to say these are the arguments that you should pass to the parent class. Now, sometimes you might do that if it made sense that, in general, dance you wanted to have, like, dance would accept two arguments, like duration and style. And when you do disco dance or dance, well, I only need duration. I already know my style, like, and maybe it's just hard-coded in, or maybe you don't pass it on at all, or something like that. So you can change the number of arguments. Or maybe disco dancers need more arguments for dance. This is a common thing. Maybe you have a class that is for like a game board, like a chess board, right? And it has properties like x and y for the coordinates. And then you find that, well, you need a 3D version of the game board because you're making like chess of the future. And so now I need x, y, and z for some of these methods. So you could override the parent method and say, well, for the 3D version, we're going to take x, y, and z. And then we're going to take the x and y, pass it on to the parent because they know what to do with that. And then we'll do something with the z. Ruby is a very flexible language. You can actually redefine methods at runtime, on the fly. So let's say these are like different files. In this file, I've got a class called developer, and I have a method called code. And it says bits. Then some stuff happens here. Who knows? And I'm going to say, you know what? That developer class we talked about earlier, let's get that back out here. Let's bring it up. Brian, why don't you come on up here? And we're going to change this method, and this is what it does now. So then after that's happened, after it's been redefined, if I make a new developer and I say code, it's going to be hacks. Because I'm assuming that what happened here is that, like, I was really, I don't know, really hopeful that those things were going to work out well, and then, like, deadlines happen, and requirements change, and the boss comes in and says, no, you just need to get it done, and so we're like, you know, we're just gonna hack it from now on. Just cut corners. All right, moving on to a new topic that gets one slide only. In PHP and in other similar languages, there is a keyword final. This means, you know, the overriding stops here. The child classes are not allowed to override this method. So it's just an additional word that you add in the signature. So not only is this a public function, this is a final public function, and no one's allowed to change it. So if I had something that extends foo and I tried to redefine bar, I would get a fatal error. Like, and they're not supported in Ruby because that doesn't fit the spirit of the language. Ruby is all about you can change things on the fly whenever you want. So final doesn't make sense in that context. But you will see final sometimes. Oh, and I say there, this cursor's just been in the way the whole time. That's probably annoying. Use this with caution. It's more often than not, final methods are a bad idea. Because it's like, who am I to say how you're going to use this class? Like, you should be able to extend it and make the changes that you need to. But if I'm absolutely sure that you should not only would not need to, but should not ever change this method, I can mark it final. All right, moving on. So we need to take a quick break. Go to the restroom, get a drink. I need a drink. All right, so we've talked about, we've got objects, we have classes, which are definition of a thing, an object, which is an instance of a thing. Classes can have properties and method. Properties is the data about them, and methods are the behavior, the functions, the ways that you interface with this class. Those methods and properties can be private protected, or public. Sometimes it can be final. There's another feature of most OOP implementations of constants. These are really similar to constants just in the global scope, if you're familiar with this. They're just constant variables that are scoped to be part of the class. Having a constant on a class is really just an organization thing. Like, if I have this one particular thing, maybe I don't need to define this constant in the global space. My entire application doesn't need to know it. It's just part of this class. Like global constants, they cannot be changed. They're constant. Like, they're set. Once they're set, they're done. They're always public. And the convention is that they should be in all caps. I think in Ruby it's actually a requirement. Complain. So constants in PHP. For a class constant, you use this keyword const, and then the name of the constant in all caps, and then you give it a value. And then once it's set, it's never going to change. So here I have editor, the value for editor vim is just vim, and the value of editor Emacs is Emacs. And the reason you might do this is when I have functions that I'm gonna pass around these values, or maybe there's a method on here on developer that says like set editor or a preferred editor. I could, in that setter method, I could say, well, the method that you gave me, is it this constant or this constant or this constant or one of my list of constants? No. Well, then I don't accept it. Like I don't know about that and I can't support it. And it's better to use constants than to just pass around these strings, because like you could typo this, you could typo this. Like if you typo that, your program wouldn't know that you meant vim and you didn't mean vi, right? But if you typo this, like you leave off the m, PHP will say, well, I don't have a constant called editor vi. This is a problem. You need to fix this. I'm going to make a warning or an error. And your IDE should be able to complete this out. So you just start typing EDE tab. Okay, yeah. The way you get to these from the global scope, I could have made the slide a little bit better. The way you get to this from the global scope is the name of the class, double colons, the name of the constant. So if I want to say print developer editor vim, then it would be vim. Print developer editor Emacs, it's Emacs. Now if I just said print editor vim, I would get a warning that says, well, that's an undefined constant, because you're trying to just access that in the global scope. That's not a thing. If you did it from within the class, instead of the word developer, it's like, I already know what class you're talking about. Give me a break. You don't need to spell the whole thing out every time. You can just use the word self. It's a keyword, self, colon, editor vim. And you'll see that here in a minute, but not in this context. Basically the same in Ruby. You don't start with like const. You just do it in all caps. And then it's like, oh, okay, I know this is a constant we're talking about here. Makes it available to the public, and it's constant. I guess can never be changed. I don't know. I just said earlier the Ruby's all about changing stuff on the fly. I'm going to assume constants can't be changed, but maybe there's a way. Statics. Statics are like constants in the way you interact with them, but they can change. So these are properties or methods, like static properties or static methods, that are associated with the class, not with a particular instance of the class. So let me show you what I'm talking about here. So a static property, in this case, in PHP, the way you do it is you just make a variable the way you would before, but you add an additional keyword. That's the word static. So I have this static variable, and it's called devsMade, and we're going to initialize it, like when we first start, which is the number 0. Now, here in my constructor, I'm going to actually take that and increment it. We're going to increase its value by 1. Now, I could use the full word developer, like I did earlier with constants, and that would work. But when you're within the context of the class, you can use either self or static is actually better to use. Because of some new features, late static binding. So I make a class called developer. It has a static property devsMade. Before I do anything with it, I just want to know developer devsMade 0. No developers have been made yet. Then Jacob goes to Kitten's code school, and now when I say developers made, it's got a value of 1. This is the thing. And now Matthew goes to code school, and now developers made, that's 2. This is not associated with Jacob. This is not a thing about Jacob or about Matthew. This is about developers, the idea, the class, the concept of developers. So this is a static property. You can access it within the class, or because I made it public, you can access it outside the class as well. Methods can also be static. This means I have a method that I can call, but not within the context of a particular developer, just in general. So here I'm moving away from funny examples and showing something practical again. This is what's referred to as the Singleton Pattern. This is a design pattern where, let's say you have some object, you have some class, and you are declaring that there should only ever be one instance of this. There should never be more than one instance of this class because it's special. In this case, it's like some config thing, and I'm saying it's a singleton. So in PHP, the way you do this, I'm taking my constructor and I'm making it private. Actually, you can make the constructor private to say that no one outside of this class is allowed to make new developers. Well, then how are you going to make new developers? You need to be able to, right? Well, I have this static function, this static method that is available. It's public, and anybody can access it. You don't need a developer in order to make a developer. It's like catch-22. So I make this method called getInstance. So in this example, I have both a static function and I have a static property. So I have this property instance. Now I make it private because I don't want someone to just say config : $instance and get to it, because I don't know that I need to make one of these until the first person asks me for it. So if you're not familiar with this syntax, so you might be familiar with the ternary shorthand operator, just like a one-line if. This is even shorter. This is the Elvis operator, because it kind of looks like the curly hair. So with this syntax, what it means is, so do I already have an instance? Okay, just return it. But I don't? Oh, well, let's go ahead and make one. And now we are within the scope. We are within the context of this class, so I can call this private function. So I can make a new instance, and I get it. And then it gets returned. So down here, when I say config getInstance, it comes in here. It sees I don't have one yet, so I'm going to make one. And then it returns it. Now right here, I'm just saying new static. Now, because earlier I was saying that you could use the word or config in this case, or the name of the class right there. You can also use it here when you're making new methods. So I don't have to. This is just kind of convenient. If I change the name of this class, I don't have to change it here. It might actually be a little bit more readable, easier to follow if you said new config. But so here I say config getInstance. Now this line, later somewhere else in my application, I say config getInstance again. So the order of operations here is that it's going to come into this method. It's going to do this check and say, do I have an instance as a static property? I do, because it was set previously. So I'm just going to return it. So these two objects are going to be exactly the same thing. So if I take this object and I say set mail server equals localhost, and I come down here and I say get mail server, it'll be like localhost. It's the same object. I know what you're talking about. There's only one instance of it. Singletons are neat. They're really hard to test. They're worth knowing about, though. We're not going to do the singleton example in Ruby, but we will cover statics. There are static properties and static methods in Ruby. They don't call them that. They don't call them static properties. They call them class variables, meaning it's a variable that's associated with the entire class, as opposed to an instance variable. And a static method, they call it a class method. It's a method that's available with the whole class. It's not an instance method. I like that naming convention. It breaks from the classical C++ style, but it makes sense. Short, it's nice. So the difference here, here, this is a method. This is an instance method. This gets invoked on a particular instance. The difference here is that you add the word self, or self dot. So when you say we're going to define a function self.devsMade, we're making a class method. So this is part of the class. Now, class variables, the difference is that you have an extra @ sign at the beginning. So there's two @ signs. That means it's a class variable. So in this case, here I went ahead and I didn't start with 0, but right here, if I said developer.devsMade, it would call this method, which returns this static property, and it would say 0. Here I say Seth developer.new, and it's and then next time when I say, also it comes in here and it increments devsMade. And then when I say devsMade here, it's 1. When I say Jarrett is a new developer, then when I say devsMade now, it's 2. So it's just the same idea. And you can do singletons, I'm assuming. All right, that was statics. That's a feature of OOP that you're likely to come across if you work in an OOP code base, and I want you to know about it. You might not use it very often because it's hard to test. Statics make testing hard, and we're all testing our code, right? So the next thing we're going to talk about is abstract classes and abstract methods. So again, keywords here are in bold. A class can be declared abstract, which means that, you know, it's like a Picasso class. It's something that you have to like get, right? An abstract class cannot be directly instantiated, which means you cannot, if I have an abstract class called abstract class, I cannot say new abstract class. My PHP Ruby is going to say, or not Ruby, PHP would say, this is a problem, you can't do that. So if you want to get that abstract class, you would have to extend it. You have to have another class that would be a more specific type of that. Because it's too abstract, I can't handle it. Methods that are on an abstract class can also be declared abstract. Most of the time when you have an abstract class, it's because there's some, like I've defined like 95% of this class, but there's a couple of things that you need to define. I'm not going to do that for you. So I have these methods, and I'm guaranteeing that these methods exist, but I'm not defining them. Like the class that extends me has to define them. It has to implement them. Or maybe it can say that they're abstract and be an abstract class itself, and you can have this huge hierarchy. So let me show you an example. So here, let's talk about abstract PHP. And here I have a functional, practical example again. I have this class model because I heard about MVC. It's all the rage, and I want to start using it. So I have this class model, which is going to, and in my case, I'm just going to map my models kind of directly to databases. I'm going to kind of take an active record style approach. So in order for my models to work, all of my model classes must have a method called getTable. But I can't define the table for every model in my base abstract class. I don't know what that is. That's an implementation detail for an extended subclass. Maybe I do have a concrete class. Abstract classes can have concrete methods. That should be another word called concrete methods, what they refer to these, where there's just like a regular method and it works. And so here, when I have a class user that extends model, user can call formatted table. That's a method that I inherited from my abstract class. So in this case here, I call getTable and I make it uppercase and I return it. So now when my abstract class user extends model, it has to, in order for this to compile, in order for PHP to execute this, I have to have that function getTable. And so I make a function getTable. Now nothing says it has to do anything, but that's, if it didn't, then it would be kind of like defeating the purpose. So in this case, it's going to return the string users. So when Joe is new user. When I say Joe, hey, what's the name? What's the formatted name of the table that this model goes in? It's going to say user in all caps. So this is kind of the idea with abstract classes and methods. This isn't really a thing in Ruby. There's not a keyword that I'm aware of that supports the idea of abstract classes. You can kind of simulate it by taking like the initializer and making it throw an exception. Like as soon as you instantiate this class, throws an exception. So you basically can't instantiate this class. But it doesn't really fit the style. Like that's not really what Ruby's about. They don't do this kind of Okay, this is the best part. That was all build-up. This is what I really wanted to talk about. It was interfaces. So interfaces is not UI. This is not user interfaces. This is like API, application programming interfaces. This is the set of public functions that you're making available. So an OO interface, it's a contract. a class that implements some interface is guaranteeing that it has the public methods of that interface. So you can use this instead of or in conjunction with inheritance. I prefer using interfaces over inheritance, but there's nothing to say you can't do both. This isn't a feature in Ruby because in Ruby they use duck typing, where it's like, well, if it looks like a duck, it talks like a duck, like it has the behaviors of a duck, then sure, we'll call it a duck. Like, I don't need to know that it is a duck. I just need to know that it can quack. So let's talk about interfaces. So Jim Rice is working on this program, and he makes this interface word typers. Well, what is a word typer? Like, I don't know what this is. Well, this is a word typer is something that has this method type. Now, I don't actually define the method. Like, there's no curly braces here. I don't have any code to like return a string or maybe do some math or put some characters together. All I'm saying, this is just the definition. This is the signature. So interfaces are small. They have, it's a contract. It's here's the list of methods that a word typer can perform. So instead of having a base class called coder that maybe is an abstract class that has a method called type that's an abstract method and it has to be implemented or overridden. Implemented. I can have a class called designer that implements word typer. So implements is a keyword here. So a designer implements word typer. Designers are word typers, and when designers type, it's CSS. Developers are word typers. They implement that interface. So when they type, it's PHP. So I do this somewhere in my application. Many lines later, I have this object. And in order for me to work with it appropriately, I need to know that it's a word typer. I don't care if it's a designer or a developer. Like, that's not appropriate. I don't care. I should know this is a word typer. So I can check. Is this object an instance of word typer? Sure is. It implements that interface. So previously I had a developer, right? And I would say, well, developer is an instance of coder? Well, yes, because like it inherits that type. You can do the same kind of check with interfaces to say, what I'm saying here is, does this object have the behavior of a word typer? So this is where you get into like behavior-driven development. I don't care what it is. I just care that it has this role. I care that it has this set of behavior and it acts like this thing. So it does. Great. You enter my if, and I say object type. So it prints CSS or PHP. Well, whatever it's going to do, I don't care. I just know that it's a word typer. Okay. This is the last thing in my presentation. This is an example of why you want to use interfaces and how flexible they can be. So let's say that we are writing software in PHP to control and run this automated pizza joint of the future. Sounds great. So there's a whole bunch of stuff in my application. It's a huge application. Within this one specific section, I'm working on the oven, right? So I've got these two classes. I have a class called pizza and a class called oven. Oven has this public function, bake. Now, I didn't talk about this before, but this is a very important, very good to use feature in PHP. Type penning. I can say, like, I can strongly type this method. I can say that if you pass me an object here, it better be a pizza. This is the only thing I am programmed to handle is how to bake pizzas, because we're going to set the baking time to 17 minutes. The baking temperature is 425 degrees. And I can't guarantee that that's appropriate for anything else. So I handle baking pizzas. So if you try to give me a banana, this will throw a fatal error. It'll say, no, you can't. This method only accepts pizzas. Great. So we wanted to start with like the minimum viable product, right? This is what I need to do to get my pizza joint up and running into the 25th century or whatever we're trying to target here. And then we start to diversify. My boss comes along and says, you know what? In a lot of times, but our oven's just cold. It's just sitting there and it's not doing anything. And I did a survey and I asked my neighbor, and so we're gonna start offering cakes too. I hired a baker, and we're gonna start doing this. So I need you can fix that, right? In your software, you make that work. Yeah, I mean, an oven could bake. Well, why couldn't it bake a cake? Let me just kind of change this a little bit. So my first instinct is we're gonna use an abstract class, because we talked about this earlier, that I can have this class. It's abstract, and it declares that it's going to have these things, and then I can get more specific and I can work on that. So I have this abstract class food, right? We're gonna bake food. A food must implement a method called getBakeTime, and it must implement a method called getBakeTemp. In a more strongly typed language in the interface, you would also be able to define like the return types. Like, not only does it have getBakeTime, but it must return me like an integer or something like that. So then I have two classes now, cake and pizza. They both extend food. A cake is a food. A pizza is a food. And for like to conserve space, I collapsed everything on the same lines. So a cake, in this case, we're going to bake it for 30 minutes at 350 degrees Fahrenheit, because we're in the United States. We don't apparently care about the difference between Fahrenheit and Celsius. So pizza, previously I had these hard-coded into my oven class. The oven was permanently set to 17 minutes at 425 degrees. That's only appropriate for the types of pizza that we bake, so I put that on pizza. And then I've got getBakeTime 17 minutes, getBakeTemp 425. So then in my oven class, I changed this signature. It's not that I need pizza here, because that's the whole point. I'm expanding it. I can bake more things. I can bake food. You can put any kind of food in the oven, as long as it is of the type food. And because up here I'm guaranteed that everything that is food would eventually have a BakeTime and a BakeTemp. When I come here, I can say, well, BakeTime is food get BakeTime. BakeTemp is food get BakeTemp. So this is using abstract classes to solve this problem, and it's a fine solution. It works. Well, my boss just acquired the craft pottery thing that's in our strip mall that where this pizza joint's running, and what they promised the board of directors is that it should be no problem. We can just kind of take over, and this great software that Jim Rice has written for us needs to also run the kiln over there. You hear this and you're like, are you kidding? Okay, so yeah, well, you would. In this case, the client's your boss. You try to fire him, you get fired. So it's like mutually assured destruction. All right, so this is the problem. Like, we need to quit crying about it, Jim, and make it happen. So, well, before we look at this, the solution is interfaces. But no, up. Okay. Before we move on, like, if we're going the abstract class route, how would I say this? Well, I've got food, and then I've got different types of food. It has like a BakeTemp and a BakeTime. Wow, what's more generic than food? Thing, right? Object, stuff, like bakeable, right? Something that's bakeable. Now, not everything is bakeable. I don't want to bake everything. Like, what are you, crazy? So instead of having... Right. So instead of trying to go the abstract class route, I'm going to go the interface route. And Jake Moore figured it out. That I need, instead of having things of a particular class, I don't care what class you are. I don't care what kind of thing you are. I just care that you're bakeable. So this is a role interface. This is an interface that defines behavior. This interface says that anything that implements this interface, this contract, this interface, guarantees that you will have a getCookTime and a getBakeTime, or cooktemp. That should say BakeTemp, really, instead of CookTime. Cooking and baking are different. Not trying to say that. This is a typo. Anyway, so I've got clay pot, right? A clay pot implements bakeable. A clay pot is bakeable. It should be cooked for 300 minutes at 950 degrees. In a more accurate representation, there would be like a ramping up time and temperatures, and it needs like an hour at this temperature, an hour at this, an hour at this. But that's beyond the scope. I don't need to worry about that right now because I'm getting a new job next week, and I need to just make this work for right now. So I need bakeable, right? So I implement this. Here, they're just the same. Oh, no, I messed that up. That should be cake was 30 minutes, and that was 17, 425, whatever. Doesn't really matter. My oven now is going to be changed to require something that's bakeable. I'm not no longer requiring food. And now I've taken my problem that I was going to solve with abstract classes that was going to make this very large and complicated web. And keep in mind, I don't have multiple inheritance, so the web is only like a pyramid. I can't go both directions with it. If you try to, it doesn't really work, and it becomes quickly unmaintainable. And I've broken it down into sets of behavior, and I've solved my problem with interfaces. Okay, so this is actually the last slide. That was the last example. If you're interested in object-oriented programming, I definitely recommend that you read up on the solid principles. This is a set of 5 design principles that you should strive to achieve in your when you're writing classes. This stands for it's like, let's see if I remember this: single responsibility principle, open close principle, Liskov substitution, interface segregation, and dependency inversion principle. Thank you. And so those are really good. They deserve their own featured talk. Just Google design pattern, OOP design patterns. There's a lot of them. There's a lot of good things. Like I showed you the Singleton pattern earlier. That's a design pattern. Dependency injection is really important to understand, especially as you get into unit testing and test-driven development. There's an idea that last. Well, I guess this really isn't part of the last example, but there's an idea of composition over inheritance. Instead of extending from a lot of things and having this big hierarchy of stuff, you should accept those things as like, you should be composed of lots of things. And some syntax things that I almost covered in this talk, but I thought were too specific. In PHP, there's a concept of namespaces. In Ruby, they have modules. In PHP, there's traits, and in Ruby, there's mixins. These are kind of ways to approach, like if you feel like you need multiple inheritance, but you don't have it, you can kind of get it. You can kind of achieve some of that behavior with traits and mixins. All of these slides are available online. I will make the link available on the meetup page or something, and also all of these presentations go onto our GitHub page, the GitHub organization for devICT. This video that we're currently still recording will be on YouTube, and then we'll put a link on our website, devict.org/videos. Does anyone have any questions? Well, thank you all for coming out and staying awake while I talk to you about something I care a lot about, object-oriented programming. And I hope to see you all in IRC tomorrow morning, 8 a.m. Central Standard Time.